Okay, so now that we have our particle system, we're going to look at how to modify that particle system over time. Now, just to clarify, the particle system does have changes over time. As we looked at the rotation, the size, the transparency, a lot of things change over time. But what if, say, you want the radius to change over time? In other words, you want it to get bigger. So not just the particle changing size, but the particle system itself to change size. So how would you do that? So change specifically in this case, you're changing the radius because let's just grab one of these dots. You can see the radius grew. So say you want the fire to get bigger. And what if you also want it to get taller? Well, taller would be the lifetime. So say you want that to go up to 6. You can see it's bigger. So those kind of changes you can do with a script. And so what we're going to do is we're going to create a game master object. The game master object is going to have a variable refer to this particle system, and then we can make changes. So that's what we're going to do in this video. So let's go ahead and make a GM object. So create empty, we'll call it GM, short for game master. And just like a DM in a role-playing game, the GM is really used for collecting various functionality that really isn't necessarily associated with any one object so much as associated with a group of objects, or you want to coordinate across objects. So yes, you're changing one object, but you're really changing it to synchronize with other objects, that kind of thing. So what we need to do is we need the GM object to be aware of this object. So what we're going to do is we're going to right click, create C#, and we'll call this, we'll also call this GM, but personally I don't like to see objects and scripts have the same name. So we'll call this GM script. I usually don't add the word script to a script. It seems kind of redundant, but again, I really don't like for an object and a script to have the same name because you can indeed reference a script from within a script. So you have to pay attention to which one you're choosing. And so it's easy enough just to have separate names so there's no doubt. So we take our GM object, we put our GM script onto it, and then we open it. Okay, so first we need to make a reference to the object that we want to be able to manipulate with this script. So specifically, it's the particle system. So public particle system, and we'll just call this fire PS for fire particle system. Now you're going to see that variable appear over here in the script. Okay, you're going to take the particle system, you're going to drag and drop it there. For want of a better term, the GM, the game master object, is now aware of the particle system. You've linked it through there. So what you do is using this variable, you can now make modifications to that. So let's back up for just a second. Let's look at our particle system. Just as a particle system is known as a component, because whenever you create an object, you have add component. So the particle system is a component. Well, the particle system is broken up into modules. So what's going to happen is everything in this top section is known as the main module. So we're going to have to make a reference to the main module to make changes to that. Each of these other titles, these are also modules. Unfortunately, sometimes the name of what you enter in the script to modify a module doesn't necessarily match the name, like emissions you modify to emit, things like that. But each one of these you should be able to change via script. So what we're going to do So what we're going to do is we're going to create some additional variables to represent and to let us modify portions of that particle system. So I'm going to paste this, and you could just pause the video. So particle system dot main module ps main is equal to fire ps dot main. So as we've seen this before, you start from a general and you drill down to more specific. So the fire ps is a particle system. We want specifically the main module. And we're saying that ps main is going to be equal to the main module. Next. Again, I'm just going to paste this, just pause the video. Particle system dot shape module ps shape is equal to fire ps dot shape. So again, we're taking a portion of this and dropping it into another variable. Now I'm hoping that you see the pattern, because as I said, the particle system is broken down into modules. So here is the main module, here is the shape module. So if we come over here, shape module. So like I said, sometimes the name matches and sometimes it doesn't. You'll see in a minute one that does not. Okay, so we have the main module and we have the shape module. Now we're going to make changes to those modules. So let's paste in the next 2 lines, and I usually do this 1 line at a time, but I want you to see the pattern of what's going on here. So we said, okay, we're going to make changes to the main module, and the main module will be represented by ps main. So let's paste this in here. See the pattern? ps main, ps main. So first we said this is going to be part of the fire ps module. Now we're going to make changes to it. Specifically, we want to change the start lifetime and we want to change the start speed. I'm not saying this is what we actually want at the moment. I'm just showing that you can make those changes to that module. So if we go back over to our module, as I said, these are the main module. So start lifetime and start speed. There's the start lifetime and there's the start speed. So it's exactly the same terminology. The verbiage is the same. Unfortunately, sometimes things don't transfer exactly the same. For whatever reason, sometimes the coding doesn't match. Like, for instance, you'll see that emission isn't emission, it's just emit. So sometimes the verbiage is the same, sometimes it is not. So let's take a look at that again. So in the main module, so whenever you see ps main, think main module, we're going to change the start lifetime and we're going to change the start speed. So let's actually run this. So let's make sure everything is working. We have the particle system. Oops, sorry, nope. We actually want the GM. And the particle system is attached to it. And the script is attached. So the script will be making those changes. Now, the particle system, as you saw running, has a start lifetime of 1. And what else did we change? A start speed. This has a start speed of 30. This has a start speed of 2. So watch what happens. It's going to be crazy. See? You've changed the initial settings via a script. Of course, this looks like nonsense and you wouldn't want it, but I just want to demonstrate. I want to have something so extreme that you would say, aha, that does change it. So right now, start speed is 2. So let's go back and change this to start speed 2. And there we go. There's our fire, our kind of square fire, but still a fire nonetheless. So now, settings that you were previously only changing at the beginning, you are now modifying in the runtime. So as it's running, you can now make changes to this. So this right now is a constant. This is a constant. If you replace those with variables, then you've done it. Then you've taken something that runs in a constant cycle and you modify that cycle. So say you want the fire to get bigger. That means this would need to change over time. See, if I was just to change this to say 5 and run it, it starts with the fire being much bigger. But what if you don't want that? What if you want it to get bigger over time? Oh, and by the way, we don't have we're hitting the max particles. That's why you got that break there. So this max particles, it's not random. It really does make a difference because there were 1,500 particles, and so no more particles could be created. So a teachable moment there. So something to take into consideration that as the particle lifetime increases, that means you're going to have more particles on the screen at the same time. So make sure you have the appropriate amount of max particles. Now, as it turns out, we don't want it to be that big, but what we do is we want this to get bigger over time. Okay. Now these two again are in the main module. So start lifetime, start speed. I already showed you where they are, but you probably don't want the fire to just get tall. You want it to get wider. So that's where this comes in. You want the shape to change, and specifically, you want the radius. So let's look at changing that now. And we do that by now referring to this variable. So again, the first two are referring to the main module. Now we're going to go down to the shape module. So again, we created the variable to represent a certain portion of the particle system. And just as we drill down into the lifetime and the speed, or the start lifetime and the start speed, in the shape module, we've drilled down into the radius. Now, if you look at this, it starts off as a radius, so shape module. It starts off as a radius of only 0.697, so on and so forth. Let's clean that up because let's make it just 0.7 even. But this is saying a radius of 1. So 1 obviously is greater than 0.7, so you'll see that it'll be bigger this time. So again, it's important to realize that these initial settings are being overwritten, is what's happening. You're overriding them. Probably doesn't look a lot wider, so let's make it a little bit more obvious. And there's something else I want to talk about, not just changing this, but the impact on the other attributes. So clearly that's a lot wider. It's so wide as it doesn't look even meaningful now. But this is what I'm getting at. If you're increasing the width, okay, or in this case, you're increasing the radius since it's actually a cylinder. If you're increasing the radius, then that means to have exactly the same effect, you really need to also increase the concentration. So that means the emission needs to increase. So if you're increasing the radius and you want it to look the same way, you really need to increase the emission as well. And that leads into the next change. And that change is the emission. So for that, it's going to be, in this case, we can just use the variable itself. So fire ps dot emit. This is how much will be emitted per frame. The reason why is because, again, the update section runs once per frame. So if you say 20, that's how many that will be emitted in this frame. So let's see how 40 looks. Well, we're definitely hitting 1,500 because see how there's that brief break? So if it turns out that you want this amount of particles, then you're going to have to increase your max. So for that one, I'm not sure if changing max particles affects memory because obviously there needs to be the ability to hit that many particles. So I'm not sure if increasing max particles causes a larger block of memory to be reserved. Certainly something to be looked at. But for now, we'll just change it. Still hitting it, but it's more full. So let's just do 3,000 even. And there you go. So there's still a very slight pause, but that you might find that you like that effect because it kind of makes it look like the red is breaking off. So it gives it a little bit more chaotic feel. So sometimes you have happy accidents like that where it's not quite what you're trying to do, but gives you the result you want. So now, basically what this video has done so far is it demonstrates how through code you can override the initial settings. And the end game is therefore to then replace the constants, as I mentioned, with variables. So let's do that now. So what we want to do is with a certain level of consistency, so based on time, we want a change to occur. Here's the problem. Update is a frame rate based. So every time update gets run, this happens. Whatever happens in the update section, whatever is written there happens. So if you have a computer that's faster, what happens in the update section will be faster. If you have a slow computer, what happens in the update section will be slower. So the key is that you need to put something in there that doesn't necessarily occur with the update. That you put I don't want to use the term buffer, but basically you put a timer in there. So rather than happening with every frame, instead a change occurs over a certain period of time. It may be a very small period of time. So just keep that in mind. Update is not based on time. It's one frame. This happens every frame that the game plays. So this would actually look different on a slower computer than a faster computer. So you have to be very careful what you do in update. That more than likely what you're going to do is you're instead going to, in the update section, you're going to have a timer of sorts. And that when that timer hits a certain time, even if it's only like a 10th of a second or a 20th of a second, whatever, then you have something occur. So let's look at how that works. So let's add a few more variables. So public, float, and we'll call this. So let's start by having the radius get bigger. So we'll call this fire radius. And the fire radius, I believe we started at 0.7. And it's F since it's a float. And the naming really is kind of arbitrary. If you want to remind yourself that's part of the shape module, then you could call it fire SHP RAD, shape radius, that kind of thing. So you're reminding yourself exactly what you're doing, where it is. Because when you start making larger and larger applications, you're going to have lots of variables. So now we have this new variable. So that would come down here to the radius. We jumped it really high there for the purposes of demonstration to see the fire get really big. So we'll bring this back here. And let's just confirm that this works, because now we've made a leap. We've gone from having a constant to a variable. Want to make sure it works. Want to make sure there's no errors. Okay, so now that is really high. But obviously the radius is small again. But the reason why that is so dense is we've got a few other things going on, and that is the emit. So we'd have to bring that back down to whatever would be appropriate. And the trick is really, you kind of don't want to be able to see the individual particles. I think that what I had earlier was a little bit too sparse, because you really could see the individual rotating symbols. That's actually not bad. That's probably a little bit too dense still, but I don't want to nitpick too much at this. Okay, so now we've put in a variable. So the key is we need this variable to change over time. So let's do this. Public float time. Call this var short for variable. I usually don't put any indication that something is a variable right within the name of the variable itself, but we will this time. And this will be, so it starts off as 0. Since there's no decimal, I don't have to drop in the F. So with every frame, and this is what I was saying about going from a frame rate calculation to a time-based calculation. So time var equals time dot delta time. For those of you who remember your math classes, delta is change in. So in other words, we want this to be the change in time. If time var is greater than let's say 0.5, then we want something to happen. First of all, time var gets reset back to 0. And the fire radius will then be increased by a certain amount. So for this, it's an increment. So we want to take its current value and drop something into it. Let's make it 0.05. And just notice an omission. Just as this is plus equals, because this should be cumulative, this also needs to be cumulative. So sorry about that. That should also be plus equals. So if this variable is increased because you take how much time has passed and you're looking for a cumulative value. So you want to know how much total time has passed. And then once a threshold has been hit, you reset that timer back to 0 and you make the change. This variable is here, and therefore the radius should keep increasing in size every half second. So let's run it. And there we go. The fire is indeed getting bigger. Now, that's only the first variable you change. There's a few more to change because as this gets bigger, we've changed the radius, but we have not changed the rate. We also haven't changed the height. And the way you would change the height in this case is how long a particle lasts. So in the when we initially created this, we had a lifetime of 1. That lifetime is probably going to have to increase to 2, 3, 4, that kind of thing. And then the concentration also has to change. So we have a constant for the emit, that's going to have to become a variable. So as the radius gets bigger, to maintain the same concentration, therefore, this would need to increase as well. And that should be a good place to stop. Now that we've begun replacing constants with variables, we will also replace the lifetime so the fire gets taller, and as we mentioned, the concentration will have to change as well, so that will have to increase in proportion to the radius. Okay, so that should do it for this video, and just let me know if there's any questions.